So guys, this is how we verify the truth table for the OR gate. Only LED is on. See, these are the two buttons and this is the LED. If I press any of the two buttons, LED turns on. See, if both the buttons are pressed, LED is on because we are using the OR condition. So OR condition says that LED is only off when both the LEDs are off. See, so let me zoom in and show you the statement here. So see that this is the OR symbol and we are using OR statement. Now guys, this is the AND condition over here. See, I press the one button, no LED turns on, press other button, no LED turns on. I press both the buttons, now the LED turns on. Now that's the AND gate. Only LED will be on, output will be 1 if both the inputs are 1. See, both inputs 1, LED is 1. I press one input, nothing happens, second input, nothing happens. When I press both, LED turns on. So that's the AND gate. Let me show you the statement for the AND gate as well. So guys, this is a statement over here. You can see this is for the AND gate. See, if both are 1, only then the LED will turn on, else it will remain off. Hello guys, welcome to learning microcontrollers. In this video, I'm gonna give you a lecture on how you can use AND and OR gate in MikroC for PIC. So for the demonstration purpose, I'm gonna use the PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And these on the left are the two push buttons I'm going to use for demonstration purpose. They will provide you the input and then we will have an LED as an output. So using this setup, we will verify these truth tables. So for the AND gate, when we will use the AND condition, then as you know, for the truth table, when both are 1, both the buttons are giving 1, only then the output, that is the LED, will be on, else the LED will be off on all conditions. And for the OR gate, only in one condition the LED will be off, that is when both the you can say that buttons are off, that both the buttons are not being pressed. So in case of an AND gate, when both the buttons are pressed, only then the LED will be on, and in the OR gate, the LED will be only off when both the buttons are not pressed. If any of the button is pressed, LED is on. So let's verify them using our MikroC for PIC programming tool. This is the normal truth table for AND gate and OR gate, easily available in every book and every website and everywhere. So you can just use any sort of truth table. I had just made this for this presentation purpose. So let's get started. So guys, this is our PIC16F877A microcontroller. So let's connect our buttons and LEDs. Let me show you how you can connect them. So these are the two push buttons we are going to use here. And guys, for each push button, we will need a 10 kilo ohm resistor each to connect it with a PIC. Now you can name the pins of each push button as VCC and V1 for the top and VCC and B2 for the bottom button. And you can shuffle these two pins, like you can call the VCC the right one and B1 the left one. Similarly for the bottom button, you can call the left one as the B2 and right one as the VCC, doesn't matter. So guys, let's connect them. So first of all, you short the VCC pin of both the buttons and then you send it to the common VCC VCC power pin of the PIC like this. Then guys, for the top button, you connect the B1 pin to the one end of the 10 kilo ohm resistor like this. From the same pin, you will take out your output. And for the output, you can use any available digital input output pin. I'm going to use a pin number C0 for the top button. Then guys, from the other end of this 10 kilo ohm resistor for the top button, you connect it to the ground like this. Now guys, for the bottom button, you connect the B2 pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin, you will take out your output. For the output, you can use any available digital input output pin of the PIC. I'm going to use a pin number C1 like this. Then guys, from the other end of the 10 kilo ohm resistor for the bottom button, you will connect it to the ground like this. In this way, our buttons are connected. Now let's connect the LED. So this is the LED. It has two pins, one longer, one shorter. Longer is the power and shorter is always the ground. Now to connect it with the PIC, you will need a safety resistor. It can be of any value from 100 to 500 ohm, or you can go the higher value as well. But higher, remember that higher the value of the resistor, the dimmer the LED will get. So what I do is that I will be using a 220 ohm resistor. You can use any value preferable to you, but you must use a resistor. It's a safety device, else there is a chance that your LED may get burned. So the top pin is the power, the bottom one is the ground. Ground you connect it to the ground pin of the PIC like this. Now for the power pin, you connect it to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, you can connect it to any available digital input output pin of the PIC. I'm going to use a pin number B5 like this. In this way, our hardware is connected. Now guys, let me introduce you to the hardware before we move on to the programming. We will verify our true tables using our MikroC for PIC programming. These over here is an LED. This is the LED we are going to use here. And guys, these two are the buttons over here, the right one, this one and this one. Okay, I just pressed them for showing you. Okay, that's all. Now let's get to our MikroC for PIC. So we write our new program. So let me zoom in so you guys can see better. So guys, here we have our MikroC for PIC version 7.2.0. You can use a higher version as well. If available, click on File, New Project. This window pops up, New Project. With it, click on Next. Write the name of the project and or get truth table verification tutorial by learning microcontrollers. That's the name of the project I wrote. You can write whatever you want. So project, this is the project folder, selected wherever you want to create the files. And this is the microcontroller tab. You select the microcontroller you are going to use. I'm going to use the PIC16F877A microcontroller. And here we have our crystal. The crystal connected to the pin number 13 and 14. That is the hardware crystal value. So the value over there is 20 megahertz. So I will write 20 here. So this is basically a crystal connected to pin number 13 and 14 on the hardware. Click on Next and Finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S to save your work like this. Now guys, the next thing is, first of all, we initialize our button pins. So I write trace C.F0 equals to 1 because our first button is at pin number C1 like this. And this command in Arduino is like pin mode input or output. For the button, it's input. So in case of MikroC for PIC, it's like trace register. And C.F0 is the pin, and 1 means it's an input and 0 means it's an output. So button is always connected to an input pin. Now initially, we give the initial state port C.F0 equals to 0. Why? Just like in case of Arduino, it is like digital write high or low. In case of MikroC, it's like port C.F0 0. 0 means it's low. So why low? Let's get to the hardware. Let me answer you why. So at this point, you can see that this 10 kilo ohm resistor connected is at the grounding end. Whenever the 10 kilo ohm resistor is at the grounding end, this means whenever the button is pressed, a 1 will be sent. So if the 1 is to be sent when the button is pressed, then your pin must be by default at 0 because it will become 1 when the button is pressed. So when the button is not pressed, it must be 0. That's why it's 0. If your resistor is connected at the VCC end, then the button will send a 0. Then by default you must be 1. So in our case it is sending a 1, so by default it must be 0. So give some initialization delay. It's not necessary to give initialization delay, but I always suggest you give it in the one-time loop like this. Now guys, copy this for the second button, paste it like this. This is for the second button. I write F1, rest will remain the same. Now the second button is at pin number C1 like this, rest is same. Now guys, for the LED, this is trace B.F5 equals to 0. Now take a look here, difference. Now I told you that it's like pin mode input or output command in Arduino. Here we use a trace C.F1 or pin and then the state either input or output, whatever you want to declare it. So in case of a LED is always connected to an output pin, so it is 0 by default. So it means 0. So this is like pin mode output. So 0 means it's an output and 1 means it's an input. So 0 for the LED. Now give the initial state. Initially the LED must be off. So we write port B.F5 equals to 0. The LED is off by default. Now again give some initialization delay for the LED as well. So guys, we have our two buttons initialized and we have our LED initialized. Let's go to the forever loop. Write down while 1. Forever loop starts here and ends here. Now first of all, we verify our truth table for the AND gate. So I write if our button is pressed, this button is pressed, port C.F0 is pressed, port C.F0 double equals to 1 like this and close it, and the other button is also pressed, port C.F1 double equals to 1 as well. Now take a look here, close this. This is the way how you give this condition. Use a double AND here. This is the AND condition. Now let's get to the truth table to see what is happening here. Now take a look here. For the AND gate, If both the conditions are on, only then the LED is on. On all other conditions, the LED will be off. So what I do is that if both are pressed, only then the LED is on. So LED is at B5, I make it equals to 1. If port C dot F0 double equals to 1 and port C dot F1 double equals to 1, then the LED will turn on. Okay, let's say else the LED is off. Now what is going to happen is that we have to press both the buttons together, only then the LED will turn on, else the LED will not turn on. So I build this code, it's built successfully. Now I write it, go to the PIC16 programmer tool, click on file, import hex file. This is the file we just created, click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. Okay, it's written. So this is our hardware over here. Let me power up the circuit from PIC16. That's good. It's powered up. Now you can see that by default LED is off. This is a good sign. I press the one button. See, no LED turns on. I press the second button. No LED turns on. I press both the buttons together. See, the LED is on. So that's the AND gate. I press one button. No LED on. Second button. No LED on. See, no LED on. No LED on. Only LED turns on when I press both the buttons together. So that's called the AND gate. This is how our AND gate is verified that we can also implement the AND gate using the programming like this. See, one button nothing, second button nothing. If both are pressed together, only then the LED is on. So you can play with the code. You can make various conditions here like C dot F0 equals to 1. Whatever the conditions you place here, only if those conditions are verified, then this will be initiated. Else it will go to the else. So that's the beauty of AND gate. So now let's get to our OR gate. For the OR gate, the symbol in MikroC for PIC is this. Simply replace this, or we simply copy it and comment it. So you can have both in the description. So it will be good for you. You have to play with the code to learn better. So I copy this and paste it here. So you just uncomment this. So you will also have the AND code as well. Now I make the OR code. Just write these two lines. This is the OR symbol in MikroC for PIC. Rest will remain the same. Now in case of OR gate, if both the buttons are on, then what should happen? Let's check the truth table. We verify this truth table as well using this condition. Now for the OR gate, it says that if both the buttons are on, LED is on. But in case if only one button is pressed, still the LED is on. See, LED is on in three conditions. Only it is off if both the buttons are off. So our LED will be on if any of the two buttons is pressed. So let's verify this. So if any button is pressed, the LED will turn on. Now we are using the OR condition here. This is the OR condition. I build this code. See, it's built successfully. I go to the MikroC PIC16 programming tool. Here, I select the file. It's I think already selected, but still reselect it. It's selected. Click on write. Okay, the new code is being written. Let's get to the hardware. So guys, this is our hardware over here. Let the code write. Okay, the code is written and circuit should be powered up. I power it up using PIC16. I click on. So it's good that no LED is on by default because we are using else LED is off. Now I press the one button. See, the LED is on. That's great because it's an OR gate. If any one button is pressed, LED must be on. See, it's on. It's on. See that? I press both the buttons, still the LED is on. That's great. Now now guys, you can see that the truth table both have been verified. So see, this is the OR gate and that was the AND gate in the back. I will give you the code in the description of the video. You can play with the code and you can derive more applications out of it. If you still have any questions, you can ask in the comments, and there will be the link to the previous prerequisite videos as well in the description. So thank you very much for your time guys and have a nice day. See you in the next video.